In this example, we will encounter the wave equation. Show that x of t, which is equal to a sine omega t minus kx, satisfies the wave equation, where omega and k are some constants. Find the relation between omega, k, and v such that the wave equation is satisfied. Okay, so let's recall what the wave equation looks like. It's basically d squared t squared of y of t is equal to v squared d squared dx squared of basically y. Okay, in this case, we're going to basically replace x with y or something like that. Okay, so this is going to become d squared dt squared of what? A sine omega t minus kx is equal to v squared d by dx squared of a sine omega t minus kx. All right. Now, let's just basically run through the mechanics of it. Okay. One factor of d by dt. We'll pull out one factor omega. A cosine omega t minus kx. V squared d by dx. We'll pull out one factor minus k. A sine omega t minus kx. Let's do it one more time. This hits again, we'll give a minus sign here, but then we'll give me another cosine. Oh, sorry, this will be cosine here. Okay, so it'll be omega squared a sine with minus sign omega t minus kx is equal to v squared. Then we pull another minus k here, but there's still over a minus sign from this, so this will be basically k squared a sine omega t minus kx. Okay, great. There's a sine omega t minus kx on both sides. We'll cancel those things out. And so we'll get, it's basically omega squared is equal to k squared v squared. Okay, so this shows that it satisfies the wave equation. And in order to satisfy the wave equation, this relation must hold true. Okay, hope that was helpful.